Hello, we are Team 3 and we're going to present about the beer craft and wastewater treatment. In Mexico, 39% of Mexican consumers preferred craft beer, while the industrial beer was of 30%, and the growth is driven by interest in better flavor and quality, although high prices remain a barrier for 59% of consumers. Also, a lot of restaurants sell a lot of beer. On the other hand, in Brazil, the beer remains the most registered beverage in the country, offering consumers a wide variety with a lot of different labels. The consumption in Brazil is the top three global markets, while in Mexico is a fifth global consumers. It's less than Brazil. Here we can see a graph of the beer consumption per person in each country. In Mexico, there's higher per capita consumption than Brazil, reflecting a strong beer culture. And in Brazil, there's less per capita consumption uh, due to its large population in the country. The water is really important in the beer production because it makes up to 85 to 95% of beer and it directly affects the flavor, the aroma, stability, safety, and production efficiency. And also, it has a lot of minerals that helps in the sensory profile, like the calcium that improves clarity and stability. Also, the sulfates and the chlorides, which add body and sweetness, and the bicarbonates that which influence the pH and also it can potentially causing off flavors when too high. In Mexico, we use about 2.4 liters of water to produce only 1 liter of beer, making it one of the most efficient brewing industries worldwide, compared to the global average of 4 to 6 liters per liter. And in Brazil, the water use ranges from 3.5 to 4.3 liters per liter, so it's a lot more than in Mexico. So we made three questions of this topic. First, what practices do breweries in Mexico and Brazil implement to reduce their water consumption and environmental impact? And the answer is that the key practices include implementing water treatment and recycling systems to avoid wasting resources, and also for cleaning and cooling, and optimizing water consumption within the brewing process itself to reduce the water to beer ratio. The second question is what opportunities exist to apply innovative technologies to improve sustainability in beer production in both countries? So the advanced technologies include using artificial intelligence to help and the Internet of Things for real-time monitoring and optimization of brewing processes. And the last question is how does water use efficiency in the brewing industry contribute to achieving the CDG 6? So the advanced technologies include using brewery water use efficiency, which supports the CDG 6 by hitting two targets. First, lowering the water to beer ratio, and also improved WUE often incorporates advanced wastewater treatment and recycling, resulting in cleaner discharge, which aligns with target 6.3. So now with the use of microorganisms or enzymes, because they are very important in the industry, for a general objective is to develop and evaluate a biotechnological system based on microorganisms capable of degrading and transforming contaminants found in the wastewater because we want to consume clean water. So that's why we need these contaminants to be out of the system, and also to improve water quality and promote its reuse because we don't want to waste water because it's a primary resource, so we don't want to waste it in agricultural or industrial processes. In the water industry, these are the common microorganisms that are used, and their application is for biological remediation, aquaculture systems, and wastewater lagoons. And now the enzymes commonly used are the lipases, which break down fats and oils, the lacases, which degrade the lining, proteases, which degrade proteins, and the cellulases, which break down the cellulose. But in the industry, enzymes are very, very expensive. So normally in the industry, they use microorganisms or fungi rather than enzymes. So, what we expect to see as a result by using microorganisms or enzymes are first, the reduced water and energy consumption because there's not only water waste, but also a lot of energy, and it's very expensive to waste that much energy. So, that's the first one. And next, the improved quality, and also to lower environmental impact because there's a lot of enterprises that contaminate and pollute. So that's why we need to optimize by using less waste. Well, by generating less waste. So the related CDGs are first the clean water because we want no contamination in our products. Also the responsible consumption and production because we want to save energy. And also the CDG 13, which is climate action. We want to maintain our product innocuous and, as I said, free of contaminants. So it's not for our safety, but for the planet as well. And finally, the industry innovation and infrastructure, because we are searching for optimization in the use of water in industries. So it's we're talking about high scales of or amount of water. So some ideas are to implement mixed microbial consortia, and also to optimize bioreactor conditions like the pH, temperature, and the dissolved oxygen, the use of immobilized enzymes like the lipases, in silica or alginate, and also to integrate biological treatment with physical methods like filtration. For a future research question, the combined use of enzymes and microorganisms improves brewery wastewater treatment by first breaking down complex organic compounds into simpler forms that microbes can digest more efficiently, increasing COD removal and biogas production while reducing energy demand. This synergy allows for smaller, faster treatment systems that produce high quality effluents suitable for reuse in non product contact operations, lowering freshwater consumption and the overall water footprint. And with the proper polishing and monitoring, reclaimed water meets strict safety standards, ensuring no negative impact on product quality while also cutting emissions through reduced aeration needs and on site renewable energy generation from biogas.